12B, we want to solve all 25 problems, and the day before AMC 12 and 10A, I released a video, preparation for AMC. If you saw that video, I told many important ideas and also before BMO, and we will use those ideas here, and also we've used in AMC 10A, 12A, and 10B. Okay, so let's start from problem number 1. It says define x diamond y to be absolute value of x minus y. This problem we had this in also 10b. For all real numbers, and it's so much easy. X and y. What's the value of 1 diamond, 2 diamond, 3 minus 1 diamond, 2 diamond, 3. So it is absolute value. Absolute value is what? If a number is positive, for example 3.4, it will be 3.4. If it is negative, for example, negative 5, it will be positive 5. And absolute value of 0 is 0. And the definition is this. Absolute value of x is x for x greater than or equal to 0. If x is negative, you should consider negative x, that negative x is positive. Now, 2 diamond 3, absolute value of their difference. 2 minus 3, negative 1, so it will be 1. Then 1 minus 1, 0. Absolute value of 0 is 0. 1 minus 2 is 1. And then 3 minus 2, or 1 minus 3, negative 2. Absolute value of that is 2. 0 minus 2 equal to negative 2. And the answer is A. AMC 12B 2022 problem number 2. In rhombus ABCD, point P lies on segment AD such that BP is perpendicular to AD. Here. AP is 3, PD is 2. What is the area of ABCD? Because it is rhombus and AD will be 3 plus 2, 5. So all sides will be 5. And if we call this H the parallelogram or rhombus, that rhombus is also parallelogram, then the answer is 5 times H. We have also another formulas in quadrilaterals and other things about areas. For example, if you have a general quadrilateral, the area will be product of diagonals times sine of the angle between times sine alpha. Now, let's solve. I want to find h. How we can find h? If you use Pythagorean theorem in triangle ABP, then it will be h squared plus 3 squared equal to 5 squared. And if you simplify, h squared will be 25 minus 9 will be 16. And h will be 4. And because h is 4, 5 times 4, 20. And the answer is this. If you want to learn important ideas, areas, and similar this problem, feel free to send message to my WhatsApp number. So the answer is D. AMC 12B 2022 problem number 3. How many of the first 10 numbers of the sequence 1 2 1 1 1 2 1 1 and so on, 3 ones 2 3 ones are prime numbers? So for example, we can see 1 to 1 is obvious. It's what squared? 11 squared. And the next one numbers, for example, the next one mod 3 is 0. And then you should consider the rest of the numbers. One trick, let me tell you, to answer this quickly, because the next numbers, if you want to prove they are prime, you should check up all divisibility of the prime numbers on up to square root of that number, and it will be so much hard. And we understand the answer will be 0. But let me tell you the complete solution. For 1 2 1, we say it is equal to 11 plus this. Let's consider 0. It will be 1 2 1. So we can say that 1 2 1 is 11 plus 11 times 10, or this. It will be 11 times 1 plus 10. For 1 1 2 1 1, we can say it is equal to 1 1 1 plus 1 1 1 3 ones. We consider 0. It will be 1 1 2 1 1. And if I want to write, it will be 1 1 1 plus 1 1 1 0 0. And you can say it is 3 ones plus. So I am solving with what idea? exactly with the idea I told you before exam, considering a small example. If you want to also know these ideas for your next exams, AME, US AMO, BMO, IMO, and National Olympiads, and other math exams, feel free to send message to my WhatsApp number in the description and comments. Now, I want to tell you for general K1s that why there are composite numbers. You say again, it will be like what? You have K plus 1 ones, and then you add all ones here, again K plus 1 ones, which here it will be K. And you consider 0, it will be 1, 1, K1s, 2, K1s. And it will be 1, 1, 1, 1, K plus 1 ones, plus again K plus 1 ones, times 10 to the power of K. How many zeros? K. And if you want to calculate this, it will be 1, 1, K plus 1 ones, times 1 plus 10 to the power of K. So it is composite number. So we can conclude all these numbers are composite numbers. We don't have any prime. So the answer is 0A. AMC 12B 2022 problem number 4. This problem also we had this in AMC 10B. Problem says in how many for how many values of the constant k will the polynomial x squared plus kx plus 36 have two distinct integer roots? So, exactly the day before exam of AMC 1012A, I released a video preparation. I told you the things here we need. For this one, 36 equal to 0. If you consider the roots are x1, x2, x1 plus x2 will be negative k, and x1 times x2 will be 36. The problem says two distinct integer roots, means x1 and x2 are integers and x1 is not equal to x2. Now, the next step, x1 and x2 are roots. If you use the formula, it will be negative b plus minus k squared minus 4ac, which will be minus 144 all over 2a, 2. Now, because x1, x2 are integers, so some of them is also integer, so k will be also integer. Now, because k is integer and roots are integers, so inside the square root should be a perfect square, and it shouldn't be 0 because we want distinct. If here it is 0, we call it discriminant. I told you. Before exam, discriminant shouldn't be 0, then we have two roots. Also, I considered in what case we have two distinct roots. Okay, so k squared minus 144 should be m squared, and m is not 0 because we want two distinct roots. And without loss of generality, I can say m is positive integer. Because if m is negative, for some negative 2, you can say plus 2. Because k is important for us. Now, we can conclude k squared minus m squared equal to 144. Now, k minus m, if you factorize times k plus m, equal to 144. Because m is positive, it is not important k positive or negative. Because m is positive, this part is greater than this part, because plus m minus m. Now, if you consider the cases, it can be 144, 1, 72, 2, 3, 48, 4, 36, 6, 24, 8, 18, 9, 16, and we can say here 12, 12. Okay, for negative numbers also, and because it is less than this 12, 12 is not possible. So let's reject this. For negative numbers also, negative 144, negative 1, for example, negative 72, negative 2. And you don't need to check all these numbers because, for example, for 272, when we find k, I consider negative of that, it will be same. I will show you now. So for 144, 144, these two things, both of them are odd or both of them are even, because plus or minus has no effect on the remainder when divided by 2. So look, k minus m, it will be bad. If it is 1, k plus m, it is 144. Then if we add up these two equations, 2k equal to 145, and it's impossible because 145 is odd. So both of them should be even or both of them should be odd. Some of them should be even. Next case, 2k is 2 plus 72, 74. K is 37. Now again, here negative 1, negative 144. Again, some of them odd, impossible. This one, 2k will be negative 74 and k will be negative 37. So here when I reach k 37, I say k is plus minus 37. For this case, 2k is 51. It's not acceptable because one of them odd, one of them even, some of them odd, but some of them should be even because it is equal to 2k and k is integer. Next one, 2k is 40, so you consider k equal to 20, and also you should consider minus of that. For this one, 2k equal to 30, so k equal to plus minus 50. For this one, 2k equal to 26, so k equal to plus minus 13. For this one, 2k equal to 25, so it is not possible. So 1, 2, 3, 4 answers times 2 because of plus minus 8 answers. So the answer is B. As I told you all these things in the preparation video exactly before exam. If you want to learn important things in quadratic function, quadratic equations, in polynomials, functions, and other things in algebra and other topics, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022, problem number 5. The point negative negative 2 is rotated 270 degrees counterclockwise about the point 31. So if you consider the points, for example, you rotate B is this point, is rotated 270 degrees counterclockwise, is 90 degrees clockwise, about the point 31, which is A. What are the coordinates of its new position C? Now let's see what we have. If we consider this line, let's fill this part, this part. Okay. We know that if this angle is alpha, it will be 90 minus alpha. And this angle, because it is 180 straight line angle, minus 90 minus alpha will be 90 minus alpha. And this part will be alpha, it is 90 degrees. So if I call this one D, this one E, I can say by these two angles, and I know AB because it is rotation about A, so AB equal AC. We can say by two angles on side between ASA triangle. ACD is congruent to triangle ABE. Now, we can say this length is what? X here is 3. And it is negative 1, so their difference will be 4. Y here, 1, negative 2, so it will be 3 here. And opposite alpha is 4, so the side opposite alpha is 4. Opposite 90 minus alpha is 3, so it will be 3. Now, if I want to calculate this, it is 3, 1. If I want to go from 3, 1 to this point C, I should go 3 units to left, so X will be 0, and Y. I have 1, 4 units to up. 1 plus 4, 5. So the answer is B. And here we've used congruent triangles, and in the video I prepared before exam and I released, I told you in geometric problems consider congruent triangles, similar triangles, and some other things. You could use that to solve these types of problems. And if you had any question or wanted to learn important ideas, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022, problem number 6. Consider the following 100 sets of 10 elements each. Here 1 to 10, 11 to 20, 21 to 30, 991 to 1000. How many of these sets contain exactly 2 multiples of 7? Okay, so if I want to write these subsets, all of them are, for example, 10k plus 1. Let's consider it is A1, it is A2, because I want to say, for example, AK. So let's write first. It is A100. Yes. And I can say 10k minus 9. Yes. And then 10k minus 8 plus 1. The last one is 10k. So we call it AK. And we want to say how many of these sets contain exactly 2 multiples of 7. Okay. Now I consider 10k minus 9, the first one. Let's consider, for example, it is x1. Now I want to consider, because it says multiples of 7, I say x1 mod 7 can be 0, 1, 2. I want to see which of them are good. 0, 1, 2, 3, 4, 5, 6. So in this case, in first case, x1 will be good and x7 will be good. In this case, x1 will be good and x7 plus 1, 8 is good. In next one, x1 is good and... sorry. In this case, x1 is 1. So the first thing that is good is x6. Or, let me check, x1 is 1. x1 plus 6 is good. So x7 is good here. And okay, so let me correct this one. It was x1 and x8. So 1 plus 6, 7 good. And the next number we don't have, because we have up to x10. For this one, x5. And the next one, for example, you say x12. We don't have x12. For the next one, x3 and x10. x10 plus 7 plus 4. Let's check. Sorry, this part let me correct, because x1 mod 2 mod 7 is 2, so you should add by 5. So it will be x6 and the next one x13. They are bad. Here it was 14. And when it is 3 plus 4 is good. So x 1 plus 4, 5, and x12. It's not good. Now this one. You say x1 is mod 7 is 4, so you add 3. And then x4 is good, x11 is good. It's not good. The next one here. Plus 2, x3 is good, and x10, it is okay. And this one, if x1 mod 7, all of them are mod 7. x1 6, so x2 is good, and x9 is good. So these things are good. So x1 mod 7 can be 0, 5, or 6. x1 is what? 10k minus 9. So 10k minus 9 is good. Or it should be 0, 5, 6 mod 7. Now, we add 9 to both sides. So 10k mod 9 will be 9, 14, 15. And we know that they will be 2, 0, and 1 mod 7. Because 9 is 2, 14 is 0, and 15 is 1 mod 7. Now, in next step, 10, we multiply by 2, 20k will be 4, 0, and 2 mod 7. And 20 is, you can subtract 7. Negative 21 will be negative 1. Negative k will be 4, 0, 2. And then k, you multiply by negative 1. K will be negative 4, 0, negative 2, and 7 plus each of them. 7 plus negative 4 will be 3, 0, and 5. So we found that k has to be these numbers. And we know We have A1 to A100. K can only be from 1 to 100. So the first one. From 1 to 7, I have all these three things. So 3 things are good. From 8 to 14, again, we have 3 good things. Up to 92 to 98, again, we have 3 good things. 99 and 100, they are 1 and 2 mod 7, they are not useful. So it is the first part, second part, and 14th part. So the answer will be 3 times 14, which is 42. Again, look, I've used the small examples, 1 to 7, each of them, and we found these things. We've analyzed modular, and I said consider different mods are useful. Look, you can solve 90% of the problems of number theory. Let me select here. The answer is B. You can solve 90% of number theory with divisibility, this sign. For example, A divides B, and modular, mod. If you know how to work with these 2 powerful tools, you can solve 90% of the problems in number theory. Then, for example, Euler's theorem, Little Format theorem, all of them are with these 2 powerful tools. LT, lifting the exponent, all these things. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. 2022 AMC 12B, problem number 7. It was also one of problems of AMC 10B. Camilla writes down 5 positive integers. The unique mode of these integers is 2 greater. So let's write, we have 5 positive integers. Without loss of generality, consider A1 less than or equal A2 less than or equal A3 less than or equal A4 less than or equal A5. So here median is what? Is A3. Now, the problem says the unique mode of these integers is 2 greater than their median. So the mode is A3 plus 2. So mode is the number that you will see it more than the other numbers, and it has unique. It is unique. So it has to be only A4 because we have only A4 and A5 that can be greater than A3. Because mode is A3 plus 2, these 2 things have to be A3 plus 2. And they are mode, we have 2 from them. So all other numbers should be different, because if they are equal, then we don't have unique mode. So A1 less than A2, less than A3, less than A4 equal to A5. That A4 is A3 plus 2, A5 is also A3 plus 2. Okay, we've considered mode, and then next thing, the median is 2 greater than A3, is 2 greater than arithmetic mean. So let's see what we have. A3 is 2 plus mean. Mean is what? A1 plus A2 plus A3 plus A4 plus A5 over 5. If we multiply both sides by 5, 5A3 equal to 2 plus A1 plus A2 plus A3. I replace A4 and A5 with A3 plus 2. Plus A3 plus 2 plus A3 plus 2. Then I have A3, 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 3A3. On left hand side I have 5A3. So if I simplify, I have 5A3 equal to 2 plus A1 plus A2 plus 3A3 plus 2 plus 2, 4. Now, in next step, I subtract 3A3 from both sides. I have 2A3 equal to A1 plus A2 plus 6. Here I forgot to multiply 5 by 2, so let's erase 2 here, 10, 2 here, 10, and then we can correct this. It will be 10, it will be 10, and 10 plus 4, 14. A1 is not equal to A2, and left hand side is even. So this part also should be even, and A1 is less than A2. And the problem says what? The problem says what is the least possible value of the mode. So if you want to find the least possible value of mode, you should minimize A3. The minimum A3 is what? A1 plus A2 should be even. They cannot be 2 because then A1, A2 are positive integer. They will be 1, 1. But A1 should be less than A2. So it can be 4. And we can say 1, 3. So A3 will be what? 18 over 2, 9. So A1 is 1. Less than 3, A2. A3 is 9. Less than 11 equal to 11. Okay, we have these 5 numbers, and the problem says mode is what? Minimum mode, the least possible value is 11. We see 11 twice and satisfy all the conditions. And the answer is D. AMC 12B 2022, problem number 8. What is the graph of y to the 4 plus 1 equal to x to the 4 plus 2y squared in the coordinate plane? Okay, I say y to the 4 plus 1 equal to x to the 4 plus 2y squared. I take 2y squared to left hand side. It will be y to the 4 minus 2y squared plus 1 equal to x to the 4. Then I can say y squared left hand side will be y squared minus 1 squared equal to x to the 4. Then I can conclude, look, when a squared equal to b squared, we can conclude a equal to plus minus b. So here I can say x squared, if I switch left hand side and right hand side, it will be plus minus y squared minus 1. So we have two cases. Case 1 is x squared equal to y plus y squared minus 1. Second one is x squared equal to negative y squared plus 1. And then if you take negative y squared to left hand side, x squared plus y squared equal to 1. And this part you can conclude y squared minus x squared equal to 1. So it is a circle. It is a circle with center 0, 0 and radius 1. It is circle, and this part is hyperbola. So let's see the choices. Two intersecting parabolas, no. Two non-intersecting parabolas, no. Two intersecting circles, no. A circle and a hyperbola. The next one is circle and two hyperbolas, no. The answer of problem number 8 is D. In coordinate geometry, there are some important things: knowing circle, finding a point from a plane, from a line, all these things. And for example, the length, the distance of two parallel lines. If you want to learn all these important things that are useful in AMC, AME, and other exams, feel free to send message to my WhatsApp number in the description comments. 2022 AMC 12B problem number 9. The sequence A0, A1, A2, and so on is a strictly increasing arithmetic sequence of positive integers such that 2 to the A1 equal to 2 to the 27 times A7. What is the minimum possible value of A2? Okay, so if you divide both sides by 2 to the 27, it will be 2 to the A7 minus 27 equal to A7. Now, I know A0 is A0, A1 is A0 plus D. A2 is A0 plus 2D. A3 is, for example, A0 plus 3D, and we can say AN is A0 plus ND. It says strictly increasing, so D is positive, and positive integers, so we conclude, because it is positive integers, from first one A0 is positive integer, and because A0, A1 are integers, D is integer, and D is positive, so we conclude D is also positive integer. So let's replace. A7 is, by this formula, is A0 plus 7D. So 2 to the A0 plus, first let's do something before replacing these things. To find A7, I say, look, because A7 is integer, it should be positive here. Because if it is negative, then it will be a fraction. For example, 2 to the negative 1 is 1/2. So because it is positive integer, we conclude the power here should be positive. A7 minus 27 is at least 1, and A7 is at least 28. And we want to find minimum A2. If you find minimum A2, then we can say minimum A7. So let's consider case. A7 also should be a power of 2. So the first thing that we can find for A7. A7 equal to 32. It is 2 to the 5. So if we check these things, 32 to the 32 minus 27, is it equal to 32? We will see it's satisfied. Then we can conclude what? A7 is A0 plus 7D equal to 32. We can also check other numbers like A7, for example, the next power of 2 is 64. Then this one will be so much larger because 64 minus 27, it will be a large 2 to the power of that will be so much larger than 64. Now here, I want to find the minimum things that are possible. A0 plus 70 equal to 32, and we want to find minimum of A2. A2 is what? Is A0, minimum of A0 plus 2D. And we will see that this number and this number, because it is plus 5D, it will be, let me write, we know it is minimum of A0 plus 70 minus 5D. A0 plus 70 is 32. Minimum of 32 minus 5D. So, the answer mod 5 should be 2. Let's check first number. If it is 12, then D has to be 6. Let's check. For 12. So, if it is 12, then 5D 32 minus D should be 4. And A0 should be 4 again. And in this part, it will be 12. And if we check, A7 will be 32. The D is 4. So, the previous one is 28. And it starts from 4. Let's check 24, 20, 16, 12, 8, 4. 4 is A0, 1, 2, 3, 4, 5, 6, 7. And it's satisfied. A0 is this. Okay. If you want to, for example, check a smaller number, we understand that the answer is B. Also, if you want to see 32 minus 5D, can it be 2 or 7? We will obviously reach that A0 will be negative. If you want to select larger D, then 4 here. Okay. So we've solved this problem as homework. You can check them. For example, let me check one of them for you. If 32 minus 5D want to be smaller, for example 7, then what happens? D will be 5 and A0 plus 70 is 32. So when D is 5, then A0 will be negative. Okay? Because we know that A0 is at least 1 plus 70. So 70 is less than or equal what? 31. So D is at most 4. So D is a positive integer, it can be only 1, 2, 3, 4. The maximum, we want to find maximum D. We saw that D4 works here. And we've solved this problem completely. If you want to know important ideas in arithmetic sequences, geometric sequences, all these things, the formulas, the identities, feel free to send message to my WhatsApp number in the description and comments. 2022 AMC 12B problem number 10. Regular hexagon A, B, C, D, E, F has side length 2. Let G. So let's draw the regular hexagon. Okay, it is regular hexagon A, B, C, D, E, F. And then the problem says G be the midpoint of AB. So G is, for example, this point. And because the lengths are 2, it will be 1, 1. And H be the midpoint of DE. It will be something like this. 1, 1. So these lengths are 2. And then the problem says what is the perimeter of GCHF. So if we want to find the perimeter of GCHF, so we have this length. All lengths are equal because you can see all these triangles. It is 120. How you understand the angle of regular hexagon? Each angle is 120 because some of the angles for polygon with n sides will be 180 times n minus 2. For regular polygon, you divide by n. So for 6, it will be 180 times 6 minus 2 over 6. It will be 30. 4 times 30, 120 degree. And 1, 2. And all these triangles here, we have this one, this one, this one, this one. By two sides and an angle between, they are congruent. Now, We need to only find one side. Let's consider all these things. We want to find x. By cosine law, in one of them, for example, in triangle AFG, x squared equal to 2 squared plus 1 squared minus 2 times 1 times cos 120 degree. Now, 2 squared is 4 plus 1 squared 1 minus 4 cos 120 degree will be negative 1 half because it will be negative cos 60. And it will be 4 plus 1, 5. It will be plus 2, 7. So x will be root 7. And because we want to find perimeter, the answer will be 4x, which will be 4 root 7. And the answer will be D. Before exam, I told some important things about geometry, cosine law, Pythagorean theorem, R is what, RA is what, in radius, X radius. Some things I can say there are around 40 important 50 formulas. I told around 10 or 15 of them. If you want to know all things that are useful, like this exam. And for your next exam, feel free to send message to my WhatsApp number in the description and comments. 22 AMC 12B problem number 11. Let f of n equal to negative 1 plus I root 3 all over 2 to the power of n plus negative 1 negative I root 3 all over 2 to the power of n, where I equal to root negative 1, what is f of 2022. Let's consider this number first. If you want to solve it easily, also in AMC 12A I solved similar problems. You should consider polar form. It means what? If you consider polar form, let's see. Here, this number. Let's call, for example, this part equal to x. This part, the whole part here, equal to y. It is x to the n plus y to the n. X is negative 1 over 2, so let's consider negative 1 over 2, and root 3 over 2. And it will be this. If we connect this here, then this angle, and the length is what? If you want to find the length of x, it will be negative 1 half squared plus root 3 over 2 squared. It will be 1 over 4 plus 3 over 4, which is 1 x squared. The length is 1, so the length of x is 1. Now, here we have 1, and this part is 1 half. So, this angle is 30 degree. So, if I want to show x, x is length of that REI theta, which this part is theta. And theta is 1, R is 1, EI 120 degree. 90 plus 30 is 120 degree. So it is x. Now, let's focus on finding y. If you want to find y, it will be negative 1 half, negative root 3 over 2. Again, the length will be 1 by similar way. And if we connect this to this point, this angle will be 30. This angle will be what? It is our theta. Will be 180 plus 60, which will be y equal to EI 180 plus 60, which will be 240 degree. Okay, now that we want to find, so Fn equal to what? Let me write with blue. Fn equal to xn equal to EI 120 degree times n plus y is I 240n. Now, we want to find f of 2022. It will be EI 120 times 2022 plus EI 240 times 2022. Now, we will see that both these things, because 2022 is multiple of 3, so this part is multiple of 360, this part is multiple of 360. So, because they are multiple of 360, they will be lie on this point. They will be 1, because it rotates and rotates. It is multiple of 360, so it will be 1. It will be 1 plus 1 equal to 2. So the answer is 2. Okay, it was polar form. If you want to learn other important things in complex numbers that are useful in Olympiad exam and also all other exams, feel free to send message to my WhatsApp number in the description and comments. Problem number 12 of AMC 2020-12B. Kyla rolls 4 for 6-sided dice. So 4 times this dice, what is the probability that at least one of the numbers Kyla rolls is greater than 4 and at least 2 of the numbers she rolls are greater than 2. So let's consider X first thing. At least one number is greater than 4 and Y is at least 2 numbers are greater than 2. And then we want to find P of X intersect Y is what? So let's calculate this. I can say P of X intersect Y, you can say 1 whole part minus P of X prime minus P of Y prime. Then we subtract P of X prime intersect Y prime twice. So I add P of X prime intersect Y prime. So let's calculate each part. At first, let's focus on P of X prime. X is that at least one number is greater than 4. So X prime is all numbers are less than or equal 4. And P of X prime will be 4 over 6 for each part. The probability that all numbers are from 1 to 4. Because we roll it 4 times, it will be 4 over 6 to the power of 4. And it will be 2 over 3 to the power of 4. So let's write 1 minus the first thing. 2 over 3 to the power of 4. Now let's consider Y prime. Y prime says at least, Y says at least 2 numbers are greater than 2. So Y prime is that one case. We don't have any number greater than 2. So here we have 0, so all 4 things are here. Or another case is that 1, 2, we have 3 case. 3, 4, 5, 6 greater than 2, we have only one number. Now, if we check this one, it will be, we have 1, 2, 2 over 6 to the power of 4. All numbers should be here. This part is, you say, we have 4, we roll 4 times, 4 choose 1 for this one, and it will be 4 over 6. The other one will be 1, 2, 2 over 6 to the power of 3. Now, let's simplify this part. 2 over 6 will be 1 over 3. And this part, 4, we divide both of them by 2. We divide by 2, 1 over 3. So it will be 1 over 3 to the power of 4 plus 4 times 2 over 3 times 1 over 3 cubed. So it will be, the denominator will be 81. 1 plus 4 times 2, 8. 9 over 81. And for this one, we can say it is 16 over 81. 2 to the 4. It's 16 over 81. And the next one is negative 9 over 89 or 1 over 9. Because we want to use common denominator, I write it like 9 over 81. Like this. Plus X prime intersect Y prime. X prime intersect Y prime is what? We have 1, 2, 3, 4, 5, 6. X is what? X says at least one number is greater than 4. Because it is X prime, we don't have greater than 4. So from here we have 0. Now, because here we have 0, X prime will be okay. Now we should focus on Y prime. At least 2 numbers greater than 2. So maybe we don't have any numbers greater than 2, or we have one number greater than 2. So here we have 1 or 0. If we have 1 here, one case, or here we have 0, 0, 4 case here, 1 case here, 3 case. Now let's consider each of them. So this part 3, 1, 0. The probability, you should say 4 choose 1 for which of them, similar to this, and then you say the probability is 2 over 6 times this part 1, 2 will be 2 over 6 to the power of 3, and here it will be 1 over 3, it will be 1 over 3, it will be 4 over 81. And this part will be 2 over 6 to the power of 4, which will be 1 over 3 to the power of 4 will be 1 over 81. And some of them will be 5 over 81. And here we will write 5 over 81. So let's use common denominator. It will be 81 minus 16 minus 9 plus 5. It will be 81, 16 and 9 will be 25 plus 5 over 81. And here it will be negative 20. 81 minus 20 will be 61 over 81. And the answer is D. Okay, if you want to learn how to solve probability problems like this, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022 problem number 13. The diagram below shows a rectangle with side length 4 and 8 and a square with side length 5. Here, 3 vertices of the square lie on 3. This was also problem of AMC 10B. 3 vertices of the square lie on 3 different sides of the rectangle. Here, this one and this one. As shown, what is the area of the region inside both the square and the rectangle? So we want to find this. So I say the answer is 25 minus area of this part. Okay, the answer is 25. If I consider this length x from here to here, it is 90, it is square. 25 minus the area of that triangle, which will be 5x over 2. Now I want to find x. Here I use similar triangles. We know it is 4, and this length is 5. So if we use, for example, let's consider it is y. If we use Pythagorean theorem, y squared plus 4 squared equal to 5 squared. So y equal to 3. If you simplify, y equal to 3. 3, 4, 5 is famous for Pythagorean theorem. And then I say it is alpha. This is 90 minus alpha. Why? Because it is 90 and this is 180. So 180 minus 90 minus alpha will be 90 minus alpha. It will be alpha. And then we know it is 5. It is also 5. So these two triangles are similar also. We can say by similar way it is alpha. It is alpha. Because it is 90 minus alpha. So we can use similar triangles to find x. Let's call this one, for example, A. This one B. This one C. This one D. And E. By two angles, I can say triangle ABC. Triangle ABC is similar to triangle BDE. Okay? ABC because alpha 90, alpha 90. And I want to find x. X is opposite of 90 minus alpha. So x over here 90 minus alpha is this part. Over 3 equal to 5 opposite to alpha over 4. So x will be 15 over 4. Now, if I replace it will be 25 minus 5 over 2, 15 over 4. And it will be 25 minus 75 over 8. Will be, if you use common denominator 8, it will be 200 minus 75, which will be 125 over 8. And it will be 15 and 5 over 8. This. 15 and 5 over 8, the answer will be D. In this problem, we've used similar triangles and exactly the day before exam of AMC 1012A. I will use a video preparation. I said, for example, consider similar triangles, congruent triangles, Pythagorean theorem, cosine law, sine law. Some formulas, circumradius is A over 2 sine A. In radius is area over S semi-meter. And all these things, X radius. If you want to know all these things that are useful again for your other exam, feel free to send message to my WhatsApp number in the description and comments. 2022 AMC 12B problem number 14. The graph of y equal to x squared plus 2x minus 15 intersects the x-axis at point A and C and the y-axis at point B. What is tangent ABC? So if we draw, let's find y-intercept and x-intercept. If we want to find x-intercept, then y should be 0. And we conclude x squared plus 2x minus 15 from assumptions of the problem equal to 0. If we factorize x plus 5, x minus 3 equal to 0. So we conclude the first one is 0, negative 5, or second one is 0, 3. Now, if we consider negative 1, negative 2, negative 3, negative 4, negative 5. Negative 5, 1, 2, 3. This part 0. Now, the next part, y-intercept. X has to be 0. If you replace x 0 here, then y equal to 0 squared plus 2 times 0 minus 15, which will be negative 15. So it's 3. And this part, let's continue a little. It will be 15. Now, it says A and C are these points and B this point. And we want to find tangent ABC. So if I consider this part alpha, this part beta, we want to find tangent alpha plus beta. And it has a formula. It will be tangent alpha plus tangent beta 1 minus tangent alpha tangent beta. Tangent alpha is opposite side 3 over adjacent side, which will be 15. 3 over 15. For beta, we use the same thing, will be negative 5 over 15. All over 1 minus tangent alpha 3 over 15. Tangent beta will be negative 5 over 15. So let's simplify as much as we can. 3 over 15 will be 1 over, because here it's good to not simplify because we want to use common denominator. It will be 15, 3 minus 5, negative 2. And in the denominator, let's see, we have what? Let's erase this part. Okay. 3, 5, 15, we have this. It will be 1 plus 1 over 15, which will be 15. 15 plus 1, 16. We cancel 15 and 15. And here, sorry, I should say plus 5 over 15 because it's not important. It's on what part. The length is 5. So let's correct this part. Here we conclude it will be 1 minus 1 over 15. And also here I should correct this. So 3 plus 5. And let me correct this part. 3 plus 5 will be 8. And 15 minus 1 will be 14. Okay. So we can conclude what? It will be 8 over 14. You can divide by 2. It will be 4 over 7. And the answer is E. Okay, here we've used this trigonometric formula. If you want to know important trigonometric formula like cotangent alpha plus beta, sine alpha plus beta, sine 3 alpha, the relationship between tangent theta, cos 2 theta, sine 2 theta. If you want to learn all these things, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022, problem number 15. One of the following numbers is not divisible by any prime number less than 10. Which is it? If you want to calculate, you should consider different mods first. Consider mod 2. All of them are odd, so you don't reach any good thing. If you consider mod 3, because we have 2 to the 66, 606, 607, let's consider 3 to the 607 is multiple of 3. So let's calculate 2 to the 606 mod 3. These types of problems have a special way. If you've solved any problem similar to this, you know the idea. If you don't know, learn here. I say I want to consider mod 3. It will be 2 squared to the power of 303. It will be 4 to the power of 303. And 4 mod 3 is 1 to the power of 303 equal to 1. So, because of this, the first case is multiple of 3. We don't consider that because it says find a number that is not divisible by any prime number less than 10. And 2 to the power of 607 is 2 to the power of 606 times 2. By previous part, 2 to the power of 606 is 1 times mod 3, so it will be 2. 2 plus 1 is 3, so part D will be bad. Now, let's consider a last term is not multiple of 3. Let's consider mod 4. We don't need to check because all of them are odd. Mod 5. So again, 2 to the power of 606 mod 5. It will be 2 squared to the power of 303. 2 squared will be 4 to the power of 303. 4 mod 5 is negative 1. Negative 1 to the power of 303. So it will be negative 1 and 5 minus 1 is 4. So B will be rejected because 4 plus 1, 5. It will be multiple of 5. 2 to the power of 607. Let's check. 2 to the power of 607 mod 5 is 2 times 2 to the power of 606. By previous part, it will be 2 times 4, which will be 8. And 8 mod 5 will be 3. So 3 minus 1 is 2. It's not good. Let's check this one. 2 to the power of 607 plus 3 to the power of 607. If you want to check this, you can easily say that 3 to the power of 607, I can write like this. 3 is congruent to negative 2. And because 607 is odd, it will be 0. So this one will be multiple of 5. So the only choice that is left is C. Okay, you can solve 90% of the problem in number theory by divisibility, something divides something, and mod. If you want to improve your problem solving, in these two things, there are lots of things you should learn. Problem solving, important ideas. If you want to learn, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022, problem number 16. Suppose x and y are positive real numbers such that x to the y equal to 2 to the 64 and log 2 of x to the power of log 2 of y equal to 2 to the power of 27. You should correct this 27, change it to 7. The correct problem is this. And if you solve for 27, the problem doesn't have any answer. Then it says what is the greatest possible value of log 2 of y? If the problem was for 27, maybe, I think probably they will remove this problem. But if the problem is for 2 to the 7, we can solve this. Now, from first part, by logarithm, I know x to the y equal to 2 to the 64. Then I take log 2 from both sides. Log 2 of x to the y equal to log 2 of 2 to the 64. So there are around 10 or 15 important formulas in logarithm. For example, left side will be y times log 2 of x. If you want to learn all of them, feel free to send message to my WhatsApp number in the description and comments. Right side will be 64. So I can say y, let's check, y equal to 64 over, we know log 2 of x is not 0. 2 of x, because x is not 1. Because if x is 1, then here 1 to the power of y cannot be 2 to the 64. Now, I replace this in I think it's better because you have log 2 of x. Write log 2 of x in terms of y. So let's write log 2 of x equal to 64 divided by y over y. And y is not 0 because the problem says they are positive real numbers. Now, I replace in second equation. So it is our first equation. It is our second equation. By using this and replacing in second equation, 64 over y, the power of log 2 of y equal to 2 to the 7. Now, if I consider log 2 of y equal to w, then 2 to the w equal to y. And if I replace it here, it will be 64 over 2 to the w, the power of w equal to 2 to the 7. Now 64 is 2 to the 6 over 2 to the w to the power of w equal to 2 to the 7. And then left hand side will be 2 to the 6 minus w to the w equal to 2 to the 7. And it will be 2 times 6 minus w times w, or you can multiply 6w minus w squared equal to 2 to the 7. And then we can say the powers have to be equal to 7, and take all things to right hand side. So w squared minus 6w plus 7 equal to 0, and then we switch left and right hand side. Now we use quadratic formula. W equal to negative b negative negative 6 plus minus square root of negative 6 squared minus 4 times a times 7 all over 2a. You should know, you should memorize quadratic formula. I released a video before exam. I explain all these things. You can use that. 6 plus minus negative 6 squared 36 minus 4 times 7 28 over 2. It will be 6 plus minus square root of 8 all over 2. And it will be 3 plus minus square root of 2 if you divide by 2. And the problem says what is the greatest one? Greatest possible value of w or log 2 of y. So, greatest possible case, and the answer is 3 plus root 2. Because it says greatest, we select plus. So, the answer will be C. As I said in the beginning of the video, if in the beginning of the solution of this problem, if you want to learn important formulas and logarithm, all things around 15 important things, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022, problem number 17. How many 4 by 4 arrays whose entries are zeros and ones are there such that the row sums, the sum of the entries is in each row are 1, 2, 3, and 4 in some order, and the column sums, the sum of the entries in each column are also 1, 2, 3, and 4 in some order. For example, the array here, look, all the entries are zeros and ones, and this sum is 2. Let me write sum of columns. On top of each column, 2, 4, 3, 1, and on left of each row, sum of the row, it will be 3, 2, 4, 1, and it will be this. So let's solve this problem. We know one column should be 1, 1, 1. So without loss of generality, suppose the first column is 1, 1, 1. So 4, choose 1. And row that is 4. Now let's consider a column that is 4. 1, 1, 1, 1. This column is 4. 4, choose 1. Column that is 4. Now, let's consider one row that is 3. So 3, choose 1. Row that equal to 3. So we can say 1, 1. And that row that is 3, we have 2 ones, 1 0. So 2 ones are in what places? So you say 3, choose 2 for the row that is 3. 0. Now let's consider. This 4 row is 4, this row is 3, this row is 4. And we know one row is 0. Other terms should be 0. You say 2, choose 1. Let me move it here. 2, choose 1. The row that is 0. For example, here it is 0. Now, we know that here One column should be 1, but because here we have two ones, the only column that will be 1 is this, so it should be 0. Now, this column should be 2, this row should be 2, because we have 1, 3, 4. These two columns, one of them should be 2, one of them should be 3, for these two columns. So we have 1, 0 or 0, 1. So we can switch them times 2 for the last part. We have 4 times 4, 16. 16 times 3 times 3, 9. 2 times 2, 4. 9 times 16 is 144. 4 times 1, 4. 4 times 4, 16. We have 1. 4 times 4, 16 plus 1, 17. We have 1. 4 times 1, 4 plus 1, 5. So the answer is 576. And the answer is D. Look here, when we wanted to start to solve this problem, we've used from the column or row that sum of them is 4, because we can say it is limited or sum is 0. One important idea for solving these types of problem is to start from limited part, the most limited part. It will be so much useful. If you want to learn these types of ideas, start from what place, how to count, and some counting problems, harder counting problems useful in AME and other exams, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022 problem number 18. It is exactly problem number 19 of AMC 10B. So let's see the video of AMC 10B problem number 19. They are exactly same. AMC 10B 2022 problem number 19. Okay, let's solve this problem. It says each square in a 5x5 grid is either filled or empty and has up to 8 adjacent neighboring squares. Why? Because look, for example, if you consider this, one neighbor, two neighbor, also if they have common vertex, it counts 1, 2, 3, 4, 5, 6, 7, 8 if it is here. If, for example, the cell is here, 1, 2, 3. Okay. Then it says either a side or a corner. Okay, the grid is transformed by the following rules. These rules are important. Any filled square with 2 or 3 filled neighbors remains filled. So if you have filled here, so let's analyze this. Let's read at first these three conditions. Any filled square with 2 or 3 filled neighbors remains filled. Any empty square with exactly 3 filled neighbors become a filled square. And this one, all other squares remain empty or become empty. Okay, so the first condition. Let's analyze here. Look, this part is filled, but it doesn't have 2 or 3 filled, so it will be white. So this one we understood. This one, it is white, it will be condition 2. It is empty with exactly 3 filled neighbors. Why? Because this one, this one, this one. So it will be black. This one is empty because 1, 2, 3, 4, 4 neighbors. But we have how many? 3 filled neighbors. And this one, why is black? Because this one is black. It says 2 or 3 is filled, 2 or 3 filled. So here we have 2. So this one will be black. This one has only 1 neighbor, will be white. This one has 3 neighbors. So it will be black. For example, this one has 2 neighbors, but because it is empty, it needs 3 filled neighbors. So it will be empty again. And this one, for example, I said has 4 neighbors filled, but because it is empty, it should have 3 filled to be black. Okay, so we've analyzed this. Analyze the rest of the problem. Okay, let's erase these parts. Then the problem says, suppose the 5x5 grid has a border of empty squares surrounding a 3x3 subgrid. Okay, how many initial configurations will lead to a transformed grid consisting of a single filled square in the center after a single transformation? Rotational reflections of the same configuration are considered different. When it says they are different, it means the problem is easier, because if they are same, you should pay attention. Or, for example, the things we've reached can be rotated or can be reached to each other by rotation or reflection, so it will be easier. And the figure are what? This figure, we should determine only this 3 by 3 to reach this. It is initial, it is transfer. So we should only pay attention to these two figures and the 3 rules that we have. Okay, let's see. I said if you want to consider different cases in the preparation video before exam, consider limited cases, the most limited case, and calculate that if you saw the preparation video before exam, again this problem is going to consider different cases. Here in this 3 by 3, what cell is good to work on? Maybe also you can work on other cells and you will reach the same solution. But I prefer to use this cell. Now let me tell you, I call this one A, B, C, D because I want to say, for example, which of them filled, which of them empty, and E, F, G, H, I. So look, if one of them filled, I say black. If one of them is empty, I say it is white. Okay? Empty, I call empty, white. So now here I consider E is black or white. Case 1. Suppose E is white. Because E is white, and now it is first condition, second condition, and third condition. By second condition. Because E here will be black. It says any empty square with exactly 3 fields. So there are 3 blacks. In other cells, like in A, B, C, D, F, G, H, I. Now we know we have 3 blacks around this at first. If I have 2 adjacent blacks, with adjacent I mean have a common side, then let's see, is it possible or not? So because we have 3 blacks, if it is black, then it is bad, because this one will be black here, because by first condition this is black and 2 of the neighbors are black, so it cannot be black. Again, if this one is black, then this one has 2 neighbors which will be black. By similar way, it is not black because this one then has 2 blacks. If this one is black, then this white cell has 3 blacks in the neighbors, 3 black neighbors, and by second condition it will be bad, it will be black. But we know here it is white. Again, if it is black, this cell will be black in next step. If this one be black, again, let's check. Okay, so this one we will see that it will be good, because the whites will be white, the black here will be white, and this, the middle one, the middle one will be black because it has 3 black neighbors. So if we want to calculate this type, this one, we should select what corner 4 times. Now, for example, this corner, here adjacent or here adjacent. So times 2, and the last one is 1. So we have 8 good cases. Now in this case, consider that we have adjacent that have same corner. Okay, this. So we know it is white. It is case 1. We set in case 1. E is white. E is here in the first step. And because we've considered the case that we have adjacent cells, black adjacent cells that have common side, so this one should be white, this one should be white. Because of this one should be white. Now the other black cells can be here, here, and here. If you have in this part, then we can see that this black cell has 2 adjacent, and by first condition here, this will be black here. Again, we have black, and it's bad. So the third black cell cannot be here, similarly cannot be here, because it will be black in next step. If it is here, it will be good. But why? Because if you consider black cells, they don't have 2 or 3 adjacent black. If you consider white cells, except the middle one, they don't have 3 adjacent black. So it will be good. Now, I have 4 cases that these 2 adjacents are on what corner? This part, this part, this part, or this part. And the third cell is unique. It will be 4 times 1, which will be 4. Now, in this case that it is white, we consider we don't have adjacent black cells. Not corners, not sides. So, here I say I consider different cases. That I select 3 corners. So, let me count. Again, like the video I told you before, consider one property. I want to consider how many black cells are there in the corners, like this. If 3 here we have, then obviously we will reach this, and it will be 4 choose 3, which will be 4. Okay, now consider we have 2 cells in the corners, and they are not adjacent. So the only possible way here, not possible because only these 2 on the corners, we have this. And if you check black cells, don't have any, for example, 2 adjacent or 3. They have 1, they will be 0. Also 0 except middle one, don't have 3 black adjacent. So it will be 4. Because here they are on sides, on one side, they can be here or here or here or here. 4. The last one is unique. It will be 4. Now, if you consider the 2 corners similar to this, we don't have this. These are white, white, white. And it is not possible. You don't have any choice to select the next one. So it will be bad. So if you select 1 in the corner, then we can select here. It is white. It should be white. It should be white because adjacent, we've considered the adjacent cases, this one. Then here you can select 2 because they are adjacent again. And it is bad if you don't select from the corners. So for example, it is white, it is white, it is white, it is white. Then in these 4 points, 4 places, you can select 2 blacks. It's not possible to select 3 blacks. So in the case that the mid cell, the center is white, we calculated 8 here, 4 here, 12 plus 4, 16 plus 4, 20. So 20 in first case. Now, let's consider second case, case 2, that E is black. Okay. E is black in case number 2 and the midpoint is black. Now, adjacent by the condition of the problem, we have 2 blacks or 3 blacks to reach black again in the mid cell center. Now, if the cells here are adjacent, for example, if we have 2 blacks that are adjacent, then this cell has 2 blacks. If third one is adjacent to this, again, it has 3 adjacent blacks or 2 blacks. Both of them are bad because then it will be black again. So we don't have adjacent cells that are black. Now, if we select, for example, this one is black, if we select this one and say it is black, then see what happens. It has to be white because adjacent are not black. It has to be white. Now here, I should select one other black. So, because this is a white cell and it has 2 blacks, 2 adjacent blacks, it shouldn't have any other adjacent blacks, because if it has 3 adjacent blacks, it can't have 3, I mean. So you can't select only one of them. If you select both of them, then let's see what's the problem, because then we have adjacent blacks and we said it is bad. If we have only 1 black here, it's bad because of this white. If you have 1 black here, it's bad because of this white. If you have 1 black here, it is bad because of this white. So here we can select. Similarly here, here, here. In this point, we can't select any black. Now we can say, okay, it is white. It was black in the case number 2. Then we conclude it is white because we've considered when it is black, it's impossible. It's this, it is white. Now, we need at least 2 blacks. If we select this one black, then this white cell will be bad because it has 3 adjacent black cells, and in the next step it will be black. So it is bad. So These two corners cannot be black. So the only possible case is opposite corners have to be black. So we have this case or this case. So we have two cases here. We've calculated 20 from previous case and 2 from this case. It will be 22. So the answer is C, problem number 19. Okay, it was considering different cases exactly with the same idea I told you before exam. And also I solved 10A, 12A problems with the same idea. I can say most of the exams we have problems like this. If they don't have formula, you should consider different cases. You should find a property and consider different cases of that property. It is also useful in BMO other exams, AME, AMC, and also you can solve hard problems with this idea. If you want to learn these types of problem and other ideas and other problems, want to be able to solve them and improve your problem solving, description. Feel free to send message to my WhatsApp number in the description and comments. 2022 AMC 12B problem number 19. In triangle ABC, medians AD and B intersect at G. We call it centroid, intersection of median. And triangle AGE is equilateral. Okay, because it says AGE is equilateral, it's better to draw this figure that is better. And here we have AD, BE, and we can also draw this one, for example, F. Then it says cos C is what? Okay, so we can say it is x because AG is an equilateral, it will be x, And look, in triangle AGC, median GE is half of AC. It only happens in right angle triangle. Why? Because let me tell you as a lemma here, it's so much useful. If you draw a median in any triangle, for example ABC, and it is M, and this one equal this one equal this one, then you can say A is 90. Why? Because it is isosceles, it is alpha alpha, ABM is isosceles, because AMC is isosceles. It will be beta beta, and angles of A plus B plus C, which this sum is 180, it will be 2, A is alpha plus beta, B is alpha, C is beta, equal to 180 degrees. So 2 alpha plus 2 beta equal to 180 degree. So alpha plus beta equal to 90 degree. And we conclude it is 90. So it is a lemma. We use this lemma and we say it should be 90 degree because AG is equilateral triangle. It will be 60. It will be 60. It will be 60. It will be 120. It will be 30. And it will be 30 also. Now, because it is 90, it is also 90, and we know the ratio that G centroid creates on median is 2 over 1. So when it is x, it is twice this. So it will be x over 2. And for this part, because it is x, it will be 2x. And for this part, you can find these things. But let's see the problem once more. The problem says find cos C. So I want to find the length of ABC. Why? Because by cosine law that I told you before, AMC, in my preparation video, sine law, cosine law are so much important. Cos C is A squared plus B squared minus C squared all over 2AB. So I should find A, B, C. A is C, B is 2x, so it's good. And let me tell you something. You can say without loss of generality, suppose x is 1 and solve this. A, B is 2. But also with x will result same thing. Now, B is 2x. Let's consider C is what? And A is what? If I want to see A is what, I say I know it is 90. And this is x, this is x. So if I draw this, or let me tell you something. Because it is 60 degree, it is 2x. So I can say it is 2x times root 3 over 2, which will be x root 3. And this part will be x root 3 over 2. And now we want to find DC. DC squared is x over 2 squared plus x root 3 squared, which will be x squared over 4 plus 3x squared. And then DC squared will be 4x1 plus 12, 13 x squared. So DC will be x root 13 over 2. So it is x root 13 over 2. Because it is median, it is also x root 13 over 2. So A will be x root 13. And now we want to find C is what? Here in this triangle, again we use Pythagorean theorem. AF squared equal to x squared plus x root 3 over 2 squared. It will be x squared plus 3x squared over 4. It will be 4 plus 3, 7x squared over 4. So we conclude AF equal to x root 7 over 2. And then it will be x root 7 over 2. And this part will be x root 7 over 2. And then we conclude C is what? C is x root 7. Now let's calculate cos C. ABC are this. And let's copy cos C. We want to calculate this. Okay. So because x squared and x squared we have in both numerator and denominator, they will be cancelled. So we don't write x without loss of generality. We can consider x is 1. A squared is root 13 squared, which will be 13. B squared will be plus 4 minus C squared will be negative 7. Over 2 times A will be root 13 times B will be 2. 13 plus 4, 17. Minus 7, 10. If you divide 10 by 2, it will be 5. And if you multiply both numerator and denominator by 13, it will be over 26. And the problem says it is equal to m root p over n. And then m plus n plus p is what? 5 plus 13 will be 18. 18 plus 26, which will be 44. And the answer will be A. Okay, if you want to learn important ideas in geometry, ideas in median, perpendicular bisector, angle bisectors, internal, external, x circle, in circle, all these things, altitudes, for example, AH equal to 2 OM, if you want to learn all these things, length of anything, AH, length of circumradius, in radius, internal angle bisector, external angle bisector, many things. If you want to learn all these things, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022, problem number 20. This problem is exactly problem number 21 of AMC 10B, and I released the video, the complete solution. Now let's see that part of that video together. AMC 10B 2022, problem number 21. Let p of x be a polynomial with rational coefficients such that when p of x is divided by the polynomial x squared plus x plus 1, the remainder is x plus 2. So let me show up to here p of x. When you divide it by x squared plus x plus 1, it will be q1x, the remainder will be x plus 2. And the next one, when p of x is divided by the polynomial p of x squared plus 1, p of x squared plus 1. This form is useful to write q2x, the remainder is 2x plus 1. 2x plus 1. There is a unique polynomial of least degree with these two properties. What is the sum of the squares of the coefficient of that polynomial? So we know always that because we've divided x squared plus x plus 1, consider the degree of p of x. P of x it cannot be 0, because if it is constant, if you divide it by something like this, the remainder will be 0. So constant is not. If the degree is 1, then for example it will be ax plus b. So let's check this one. Let's consider it is 1, it is 2. So by 1 ax plus b, if you divide by x squared plus x plus 1 times q1x, Because the degree here is 1 and the degree here is 2, it will be exactly equal to this, and q1x equals 0. So a is 1, b is 2. And if you use second part, by similar way, ax plus b equal to 2x plus 1, a equal to 2, and that's a contradiction. So the degree is not 0, the degree is not 1. If you consider the degree is 2, so coefficient will be ax squared plus bx plus c. And we consider it will be x squared plus x plus 1. q1x will be a constant. Let's consider q1 plus x plus 2. Because if it has x, then what's the problem? Then we have degree 3 here. It will be this. It was first one, and by second one, ax squared plus bx plus c equal to x squared plus 2. The problem says x squared plus is divided by x squared plus 1. Why have written x squared plus 2? Okay, let's check. Yeah, so let's check again the first part. We've reached contradiction. Because we are working only by remainders, we can reject again 1. Let's reject 2. It will be x squared plus 1. Again, by the same way, q2 plus 2x plus 1. Now, here the coefficient of x squared, if we consider this, the coefficient of x squared in first part is a, and second part is q1. In this equation, it will be q2. If we consider coefficient of x, here it will be b. On right side, it will be q1 plus 1. Here again, it will be b. On right side, it will be q2 plus 2. Because we know q1 equal to q2, it will be q1 plus 2. So because of this part, 1 equal to 2, which is contradiction. So degree 2 is not possible. Now let's check degree 3. Okay, now because the degree of p of x is 3, so p of x equal to ax cubed plus bx squared plus cx plus d. Now, because the remainder here is 2, so I solved a similar problem in AMC 10A and 12A. It was what? I think 12A. I think in both of them. I'm sure in 12A we had that problem. If you consider an x that x squared plus x plus 1 equal to 0. For example, x squared, an x that x squared equal to negative x minus 1. Then in this case, p of x, because this part will be 0, p of x will be equal to x plus 2. So it means what? When x squared is negative x minus 1, x cubed is x times x squared, which will be negative x minus 1, which will be negative x squared minus x. X squared is this, so negative x squared. So x plus 1 minus x here, so it will be 1. Okay? Now, we understand x cubed is 1 in this case, so let's analyze all these things from this equation and the things here we've reached. If we analyze 1, p of x will be what? X cubed is 1, so it will be 8. It will be plus b times x squared is negative x minus 1 plus cx plus d equal to 0. Equal to x plus 2, the remainder. Now here, I say a minus the coefficient of x. On left hand side is negative b plus c equal to 1. And the coefficient of constant term, it will be a minus b plus d equal to 2. Okay, we have these terms. Now, if I find b, c, d, a, b, c, d that satisfy this, it's good. We can work on first equation. Let's use same thing for equation number 2. In equation number 2, I want to find x at x squared plus 1 is 0. So x squared is negative 1. So if I replace in p of x is ax cubed plus bx squared plus cx plus d. It will be a times x squared, which is negative 1, plus bx squared negative 1, plus c plus cx plus d. equal to what? Equal the remainder, equal 2x plus 1. So, here, if you consider coefficient of x, on left hand side will be negative a plus c equal to 2. And if you consider coefficient of constant term, negative b plus d equal to 1. Okay, now let's try to write all these equations. Negative b plus c equal to 1, a minus b plus d equal to 2. Let's see, can we find ABC that satisfy this? Negative b plus d equal to 1. It is because it is only correct for some special x. It is not necessary that all these equations will be satisfied. But it is sufficient. If we can find ABCD that satisfy this, then we have the two equations that the problems want, and the assumptions of the problem will be satisfied. Here, we try to find ABCD by replacement. Okay, so from this part, I say C is A plus 2. So I found C in terms of A plus 2. Also, I write C is 1 plus B. So I found C. Let's say something. Because C is A plus, I am thinking, a little better. Also, that way works. I say A is, if you take A, C minus 2, I write A in terms of C, and also B is C minus 1. If you take B, negative B to right hand side and 1 to left hand side, and then switch left hand side, right hand side, also similar way here. Now in this case, D is what? Is 1 plus B. Because we know B is D, so it will be 1 plus C minus 1. It will be 1, negative 1 will be cancelled, it will be C. Now if you replace here, A is C minus 2, negative B is C minus 1, D is C equal to 2. So C negative C will be cancelled. So C minus 2 plus 1, C minus 1 equal to 2. So C will be 3. So D will be 3, A will be 3 minus 2, 1, 3 minus 1, 2. So A, B, C, D. A is what? A is 1. B is what? B is 2. C is what? C is 3. D is what? D is 3. So we found all these 4 numbers and satisfy the assumptions of the problem. The problem wants what? Sum of the squares of the coefficients of that polynomial. Okay. So it will be a squared plus b squared plus c squared plus d squared. A squared is 1, b squared is 4, c squared is 9, d squared is 9. 9 plus 9, 18 plus 4, 22, 23. So the answer of this problem is 23, and the answer is E. Okay, I've used exactly the same idea in AMC 12A. If you want to find these important rules, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022, problem number 21. This problem is exactly problem number 22 of AMC 10B 2022. Now we can see the solution of this problem that I released before. AMC 10B 2022, problem number 22. Let S be the set of circles in the coordinate plane that are tangent to each of the 3 circles with equations. X squared plus y squared equal to 4, x squared plus y squared equal to 64, and x minus 5 squared plus y squared equal to 3. What is the sum of the areas of all circles in S? So, the equation of circle, if you have x minus alpha squared plus y minus beta squared equal to r squared, the center of this circle will be alpha beta, its center, and the radius will be r. So, we have these 2 things. Now, for each of them, the first one, center is 0, 0. Let's consider it is first one. It is second circle, third circle. So, C1, let's consider centers and then consider radius. C1 is center, 0, 0 origin, and R1 is 2. C2, the radius center number 2. Again 0, 0, and radius number 2 is 8. C3 is 5, 0, and radius 3 equal to root 3. So let's draw these 3 circles. Okay, the 3 circles are these. We should find all circles that are tangent to each of the 3 circles with equation. So let's find all circles. So, okay, type 1 are these circles. If you want to find the radius of these circles, it has proved that these points are collinear. So suppose, for example, it is O1. So we know the radius is 2. Here it is R. And we know the radius here is 8. So 2 plus R equal to 8. So 2 plus 2R equal to 8. So 2R equal to 6. So R equal to 3. So we have pi R squared here, pi R squared here. It will be 2 pi R squared. So it will be 2 pi 3 squared. And 3 squared is 9. 9 times 2, 18. 18 pi. So let's consider other types of circles. Okay, in this case, we have another type of circle and we have 2 types of that. One of them, let me show you one of them. This one, and the other one, so let me just pay attention not to copy any other thing. Okay, the next one also will be this. Will be similar to that, yes, this one. Around these points, approximately. So, it will be this, but I calculate one of them multiplied by 2. So let's move it here. Pay attention to focus on this. So again, this circle, these things have the common point. Also these things you can see. Okay, so here again, if we consider O1, and the radius here will be 4, because the whole part is 8, and this part, no, let's see, let's make sure. Okay, yes, it is 2. The whole part is 8. Now let me tell you something. You should extend this, and it will be the touch point. If you draw a little bigger, it will be this. It should be tangent. It will be 2, 2. And then this part is what? R minus 4, because it is R, it is 4. And this part will be R. So, what can we conclude? We know this part is 8. So, 2 plus R minus 4 plus R equal to 8. So 2R minus 2 equal to 8. So if you add 2 to both sides, 2R equal to 10 and R equal to 5. So pi R squared for this one, pi R squared for the other one I showed you in the beginning of this type, 2 pi R squared will be 2 pi 25, which will be 50 pi. So 50 pi here, 18 pi here. Let's focus on the third type. It is third type if we want to find again the radius. Here will be O1, R1, R1 to 2 plus 2R equal to 8. So R equal to 3. So we have something like this here. So it will be each of them pi R squared. It will be 2 pi R squared. 9 times 2, 18 pi. It will be the fourth type. And here, if we consider that, it will be tangent here. This one. If you want to prove that y, for example, these points are collinear, you can draw this. You can say O1, for example, M is perpendicular to tangent line. OM is perpendicular, so they should be same line, because they should be parallel, and also they have common point M, so they should be same line. So here we can consider it is R, and this fourth also will be R. So because it is 2, this part will be R minus 2, and R plus R minus 2 is radius of this. It is 8. It is also 8. R plus R minus 2, which will be the whole part, it will be 8. So 2R will be 10, so R will be 5. So we have 2 types of this circle like previous ones. You have, for example, something like this also here. So you say pi R squared for area of each of them, so it will be 2 25, 50 pi. So let's see all the things we've reached. 50 pi plus 80 pi, 68. 68 plus 50 will be 118. 118 plus 18, which will be 136. So 136 pi, which will be E. If you have question or want to learn these types of problem, feel free to send message. My WhatsApp number, the description and comments. Working with circles, collinear centers, solve problems like this. If you solve, it will improve your problem solving. AMC 12B 2022, problem number 22. This problem is exactly problem number 23 of AMC 10B 2022. I solved this before and I released the video. Let's see that video again. AMC 10B 2022, problem number 23. And Emilia starts on the number line at 0 and crawls in the following manner. For n equal to 1 to 3, Emilia chooses a time duration Tn and an increment Xn independently and uniformly at random from the interval 0, 1. During the nth step of the process, Emilia moves Xn units in the positive direction using up Tn minutes. If the total elapsed time has exceeded 1 minute during the nth step, she stops at the end of that step. Otherwise, she continues with the next step, taking at most 3 steps in all. What's the probability that Emilia's position when she stops will be greater than 1? Okay, so we know x1, all these things are between 0 and 1 because the problem says. So we conclude x1, x2, x3 and t1, t2, t3 belongs to this interval 0, 1. So it says the probability that Emilia's position when she stops will be greater than 1. So in first part, it cannot be greater than 1 because x1 will be less than 1. So the condition, if in second step they want to reach greater than 1, means P of t1 plus t2 greater than 1 probability of this, because then the end will be stopped, because it says if the total elapsed time has exceeded 1 minute during the nth step, so it is for second step. And then P of x1 plus x2 also be greater than 1 plus P of t1 plus t2 less than or equal 1 means it stops at last step, step number 3, but P of x1 plus x2 plus x3 will be greater than 1. We should calculate this. So let's calculate first this part, t1, t2. So if you want to consider t1, t2, you should consider it has 2 dimensions, t1, t2. You should consider the area. It is one important idea, also useful in other AMC problems. Also in CSAT problems for entrance exam of Cambridge. If you want to know these types of ideas like this, feel free to send message to my WhatsApp number in the description and comments. Okay, you consider 1 here, 1. T1, T2 are in this area, the whole area. But T1 plus T2 should be greater than 1. So if I draw another line like this, T1 plus T2 greater than 1 will be this area. So it will be 1/2. Because the area of this part over the area of this. 1/2 over 1, which will be 1/2. This part also will be, say, 1/2. This part will be the area of here. It will be 1/2. And for third part, we have 3 conditions here. We have 3 variables here, x1, x2, x3. So we should consider 3D. So if we consider this part, it is, for example, x1, x2, x3. Should consider 1 here, 1 here, 1 here. If I want to draw, it will be this part, for example, this part, and all of them will be 1, we should calculate the area of the volume of this inside this. If you want to calculate, it's better to draw a cube here to understand it completely. So if you want to find the area here, it means connect these things and try to find the area. It will be something like this. The area here, you can consider, for example, this altitude, this area, but a better one. This altitude, then the area of this part. So the altitude here is 1 times. The area here is what? 1 times 1 over 2 and over 3. And then over 3, because it is similar like this, a point that is connected to these things. The formula of volume is this. If you want to know all things about volume of different shapes, feel free to send message to my WhatsApp number in the description and comments. And the whole area is the volume of cube, which will be over 1 cube. Now, if we simplify, 1 over 2 times 1 over 2 will be 1 over 4, plus 1 over 2 times this part, which will be 1 over 6. And it will be 1 over 4 plus 1 over 12. And it will be 12, 3 plus 1, 4 over 12. Sorry, I've calculated less than 1 will be this. Because it is greater than 1, you should say 1 minus this area. So let me correct this part. 1 minus 1 over 6 will be 5 over 6. So it will be this part will be 5 over 6. And it will be this. 1 over 4 plus 5 over 12. If you factor from 12, it will be 3 plus 5, which will be 8 over 12. And if you divide both numerator and denominator by 4, it will be 2 over 3. And the answer will be C. Okay, if you have a question or want to learn same things like this, feel free to send message to my WhatsApp number in the description and comments. AMC 12B 2022, problem number 23. And this problem is exactly problem number 25 of AMC 10B 2022. I solved this problem completely and we can see the solution. Again, AMC 10B 2022, problem 25. Let x0, x1, x2, and so on be a sequence of numbers where each xk is either 0 or 1 for each positive integer n. Define Sn equal to sigma from k0 to n minus 1 xk times 2 to the k. Suppose 7 times Sn is congruent to 1 mod 2 to the power of n for all n that is greater than or equal 1. What is the value of the sum this? Okay, again and again for this problem we should use small examples. I told a small example in the video exactly the day before AMC 1012A, and if you saw that problem here by small example you can find a pattern, and then we can solve the problem and also we can prove it by induction. So let's see. S1 by the definition is x0 and the problem says 7Sn. So for n1 let's analyze. 7S1 mod 2 is 1. So S1 mod 2 is 1. S1 is what? It's x0. So x0 mod 2 is 1. And because they are either 0 or 1, so x0 is 1. The first thing that we concluded. Now, let's consider n2. Again, another small example. S2 is x0. This form of problem solving is so much useful and it proves your problem solving, but there are some other levels you should learn after considering a small example. It is not finding only pattern. Find how to prove. And it's useful also in IMO problems. And we can solve completely those problems. x0 plus 2x1. And we know 7s2 mod 4 is 1 by the assumption of the problem by here, if n is 2. From previous part, we found x0 is 1, so 1 plus 2x1. And if we replace it here, 7 mod 4 is negative 1. S2 is what? 1 plus 2x1 is 1 mod 4. So negative 1 minus 2x1 is congruent to 1 mod 4. Now, we take negative 1 to right hand side as negative 2x1 is congruent to negative 2 mod 4 plus 2, sorry. Plus 2 mod 4, if you take negative 1 to right hand side, it will be positive 1. And then when we divide by 2, because 4 is multiple of 2, we should divide. We should divide by GCD of 2 and 4, which is 2. It is an important rule in modular. If you don't know, feel free to send message to my WhatsApp number in the description and comments. Okay, mod 2. So x1 can only be 0 or 1. So x1 has to be 1. Now, the next case, x1 is 1. Let's check n3. For n3, s3 equal to x0 plus 2x1 plus 4x2. Now, x0 is 1, x2 is 1, so 1 plus 2 plus 4x2, which will be 3 plus 4x2. Now, s3, 7 times s3 is congruent to 1 mod 2 to the 3, which is 8. 7 mod 8 is negative 1. So negative 1 times s3, which is 3 plus 4x squared, 4x2, is congruent to 1 mod 8. So negative 3 minus 4x2 is congruent to negative 1 mod 8. Now we take negative 3 to right hand side, 4x, negative 4x2 is 3 plus 1, 4 mod 8. If we divide both sides by 4, let's divide both sides by negative 4. Then x2 will be negative 1 mod 2, or x2 is 1 mod 2 congruent. So we conclude x2 is also 1. Okay, if we consider x0 is 1, x1, 1, x2, 1. So let me write x0, 1, x1, 1, x2 also is 1. Now, let's consider n equal to 4. So, s4 equal to x0 plus x1 times 2, or 2x1 plus 4x2 plus 8x3. So x0, 1, 2, 4, which will be 7 plus 8x3. And also, we know 7s4 is congruent to 1 mod 16. Okay, 7s4 is congruent to 1 mod 16. Now, if we replace s4 with 7 plus 8x3, it will be congruent to 1 mod 16. 7 times 7, 49, plus 7 times 8, 56, x cubed is congruent to 1 mod 46, mod 16. Then if we take 48, 9 to right hand, it will be negative 48 mod 16 now. If we divide both sides by 8, 7x cubed, 7x3 is congruent to negative 6 mod 16 by 8 too. So here you can easily see 7 mod 3 is 1 and negative 6 mod 7 mod 2 is 1. So it will be x3, negative 6 mod 2 is 0. And because x3 can be either 0 or 1, so x3 has to be 0. So we found the first one, that is 0. So let's write it. x3 will be 0. Now, x4, let's write some more. If we consider n equal to, we've checked 4 and 5. So s5 equal to x0 plus 2x1 plus 4x2 plus 8x3 plus 16x4. x0, 1, x1, 1, x2, 1, x3, 0. So it will be 4 plus 2, 6 plus 1, 7 plus 16x4. Now, we know by the assumption of the problem, 7s5 is congruent to 1 mod, this part is 2 to the n, which is 32. And if we replace s5 with this part, it will be 7 plus 16 x4 congruent to 1 mod 32. Now, 7 times 7, 49. So we write 7 times 16, x to the 4, 49. Take it to right hand side, negative 48, mod 32. Now, let's divide both sides by 16. If we divide both sides by 16, 7x4 equal to negative 3 mod 2. If we consider all things mod 2, then x4 will be 1 mod 2. And because x4 can be either 0 or 1, so x4 will be 1. Now, let's replace. Here, x4 is 1. We've considered up to n5. Let's consider n6. And let's write n6. We can write it after this. Okay. n6. So s6 will be x0 plus 2x1 plus 4x2 plus 8x3 plus 16x4 plus 32x5. Now x4 is 1, x3 is 0. It is 1, it is 1, it is 1. And if we calculate this, it will be 7 plus 16, 23 plus 32x5. And 7s6 mod 64 is 1. Now, 7s6, 7 times s6 is 23 plus 32x5 is congruent to 1 mod 64. So, here, 7 times 23 is what? 1, 4, let's calculate. 7 times 23, 21, we have 2. 161 plus 32. x5 is congruent to 1 mod 64. If we take 165 to right hand side, 32x5 will be negative 160 mod 64. And if we divide both sides by 32, it will be x5 is congruent to negative 5 mod 2. And it is also 1, so x5 is 0 or 1, so x5 has to be 1. So we've solved like this, x5, 1. Let's check one more case, x6, and then try to generalize this. So s6, if n is, we've checked up to n6, n7. Then I can say S7 is x0 plus 2x1 plus 3x plus 4x2 plus 8x3 plus 16x4 plus 32x5 plus 64x6. So x0 is 1, x1 is 1, x2 is 1, x3 is 0, x4 is 1, x5 is 1, and x6 we want to calculate that. So it will be what? 7 plus 16, 23 plus 32, which will be 55, plus 64, x to the 6, and 7, s7 mod 1 to 8 should be 1. Now, if we replace s7 with this, it will be 7 times 55 plus 64, x6 is congruent to 1 mod 1 to 8. So, let's calculate. 7 times 55, it will be 385 plus 7 times 64, you can say it's 7, look, instead of 7 you say 6 plus 1 times 64, x6 is 1 mod 1 to 8, but 6 times 1, 64 is multiple of 1 to 8, so you can cancel that, it will be 0, so we conclude 385. 385 if we subtract, so let me write on left hand side 64x6, right hand side. 385 is congruent to, if we subtract 256, let's subtract 256 from this. 15 from 6, 9 will be 7, 2, 1 to 9. So if we take it to right hand side, 1 minus 1 to 8, it will be negative 1 to 8, mod 1 to 8, and then if we divide both sides by 64, x6 will be negative 2 mod 2, which will be 0. And because x6 can be 0 or 1, it will be 0. So here we found next 0. And we conclude x3 is 0, x6 is 0, and we guess. Let me write the things that we guess. x7 is 1, x8 with 1, x9, 0, and so on. And you can prove it by induction. I will prove, for example, x3k equal to 0. By induction, you can do the others as homework, and you can also comment your answers below this video. But first, let's solve the problem, then I will tell you proof of one of them by induction. So, X 2019. 2019 mod 3 is what? First, let's calculate this. 2 plus 1, 3 is 0. So, because we said the only things xi's that are 0 are x submultiples of 3. So it is 0. 2020 will be 1. 2021 will be 1. 2022 will be 0. So it will be 2 times 1 plus 4 times 1 will be 6. And the answer is A. And now, let me tell you the proof of, for example, why x3k is 1 and 3k plus 1, 3k plus 2 are same. So, suppose I know from, for example, x0 to 1 to 3k minus 1 is okay. I want to prove for 3k that x3k is 0. So, I consider s3k plus 1. It will be what? It will be x0 plus 2x1 plus 2 squared x2 plus 2 cubed x3 and so on. For example, plus 2, let's write some of them, plus 2 5x6 x5 plus 2 6x6, and at the end you write 2 to the 3k minus 2 a 3k minus 2 plus 2 3k minus 1 a 3k minus 1 and plus 2 to the 3k a 3k. Okay. Now, if we calculate, we know x0 is 1, it is 1, it is 1, it is 0, it is 1, it is 1, it is 0 again. And then, if we multiply, if we want to calculate s3k plus 1 first, it will be 1 plus 2 squared, then plus 2 to the 4 plus 2 to the 5, then plus 2 to the 7 plus 2 to the 8. Or let me tell you something. Oh, let me write first. Plus, at the end, we write 2 to the 3k minus 2 plus 2 to the 3k minus 1 by induction. Sorry, it's not a, it's x. X, and plus 2 to the 3k, x 3k. Now, if we calculate from this part to this part, I can say it will be 1 plus 2 squared plus 2 cubed 2 to the 3k minus 1 and then subtract minus 2 cubed plus 2 to the 6 plus 2 to the 3k minus 3 plus 2 to the 3k x 3k. So if we simplify, first term here is 2 to the 3k minus 1. It is this part. And this part, you should know a famous identity. I said in most of my videos that r squared to r to the n equal to rn plus 1 minus 1 over r minus 1. Here, I've used r is 2. Here, r, we factor from 8 first, and then it will be 1 plus 1, 8 squared plus, the last one is 8 to the k minus 1, because we factor, it will be 8k minus 2. Plus 2 to the 3k x 3k. So, here, let me not erase it to use it again. It will be 2 3k minus 1 minus 8 times. It will be 8k minus 1 minus 1, 8 minus 1, which is 7, plus 2 to the 3k, x to the 3k. So, now here, next level, it is what? It is equal to s 3k plus 1. Now, we know that 7 s 3k plus 1 is 1 mod 2 to the power of 3k plus 1. So, we can say, if we multiply 7 by this, it will be 7 times 2 to the 3k minus 1 minus 8 times 8k minus 1 minus 1 plus 7 times 2 to the 3k x 3k is congruent to 1 mod 2 to the 3k plus 1. Now I can say 7 is 6 plus 1. So 6 times 2 to the 3k mod 2 to the 3k plus 1, because it is multiple of that, is 0. So we don't need to calculate that. And then 7 times 2 to the 3k, again you say 7 is 6 plus 1. 6 times 2 to the 3k is 0, because it is multiple of 2 to the 3k plus 1. So it will be 2 to the 3k and minus 7 for this part. Here 8 times this will be negative 8 to the k, which will be 2 to the 3k, minus this plus 8, and plus 2 to the 3k, x 3k is congruent to 1 mod 2 to the 3k plus 1. By 8 minus 7 is 1, this one, this one. This one will be cancelled. And if we divide both sides by 2 to the 3k, it will be 1. We can also cancel 2 to the 3k and negative 2 to the 3k. And it will be 0 because we subtracted these things. If we divide both sides by 2 to the 3k, x3k is congruent to 0 mod 2. So because x3k can be 0 or 1, so x3k will be 0. And I proved by induction. You can also, by similar way, try to prove that x3k plus 1 plus 2 are 1. And x3k is 0 is k at least, for k at least 1. Okay. So this was the proof of this problem. And again, I solved this with the same way of many problems we've solved before, also in AMC 10A, 12A, and the preparation video. I said consider a small example, then find the pattern, try to prove it. And if you saw my ideas, my videos, you could easily solve many problems in AMC 10B, also 12B, 10A, 12A, and also other exams. If you want to prepare yourself for AME and want to learn different ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments, because there are around 40-50 important ideas, formulas in each topic: combinatorics, geometry, algebra, and number theory. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. And please don't forget to subscribe, turn on notification, and like the video. Thanks for watching this video. Have a great day. See you next time. Bye bye. AMC 12B, AMC 12B 2022, problem number 24. The figure below depicts a regular 7-gun inscribed in a unit circle. What is the sum of the fourth power of the length of all 21 of its edge and diagonals? But here we have 7x, if you see. We have 7y, we have 7z. And all the lines are 21. You can say 7 choose 2, 7 times 6 over 2, which is 21. Also, the problem says 21. So, if you see, we have 7 y's, 7 x's, 7 z's. So, the answer of the problem is 7x to the 4, because we have 7x to the 4 plus 7y to the 4 plus 7z to the 4. We should focus on finding x to the 4. Let's factor x to the 4 plus y to the 4 plus z to the 4. Okay, I say each of them. Let me at first tell you something. If we have a central angle here, I want to find the length if we know the angle is what in terms of angle. So, for example, this arc, let me show. This arc is 2 alpha. If we draw the altitude here, it will be alpha, alpha. It is central angle. Here, then we know the unit, it says unit circle. So the radius here 1, 1. So this part will be 1 times sine alpha. So it will be sine alpha. This part also will be sine alpha. So the length here, for example, let's call this one AB. AB will be 2 sine alpha. Now, here, if I consider this part 2 alpha, it will be what? 7 times 2 alpha equal to 360. So here we consider alpha equal to 180 over 7. Now that we know this, x will be equal to 2 sine alpha, but for y we have 2 alpha here, 2 alpha here. Y will be 2 sine 2 alpha, and z, it will be 2 alpha, 2 alpha, 2 alpha, z will be 2 sine 3 alpha. So it will be 7 times x to the 4, it will be 16 sine to the 4 alpha, plus y to the 4 is 16. All of them have 16 because if you use these things, and let me tell you something, we factor from 16, it will be sine alpha to the 4 plus sine 2 alpha to the 4. Let me move it to left. Plus sine 3 alpha to the 4. And now we want to calculate this. So let's focus on this part. If I consider this part as, for example, t, the answer is 7 times 16 times t. Let's focus on finding t. T is what? It's sine to the 4 alpha plus sine 2 alpha to the 4 plus sine 4 to the power of 4, sine 3 alpha to the power of 4. Now, if I consider sine theta with trigonometric, with complex numbers, I can say ei theta. Ei theta is what? Sine theta. Let me write cos theta plus I sine theta. So, if I write this and say minus e negative I theta all over, so e negative I theta will be cos negative theta is cos theta, and here will be negative I sine theta. So it will be 2i sine theta. So if you divide by 2i, it will be the thing we want, sine theta. Now, let's consider this. For sine alpha, I say ei alpha, let me write ei alpha minus e negative I alpha over 2i to the power of 4 plus e 2i alpha, or let's write ei 2 alpha minus e I negative 2 alpha over 2i is negative 2 alpha. 2i to the power of 4 plus the last one ei 4 3 alpha minus e I negative 3 alpha over 2i to the power of 4. So I to the power of 4 is 1 because I squared is negative 1. So I can factor from 1 over 16 all of them and for each of them. Let's calculate. The first one is e. You should use this identity. That's x minus 1 to the 4 is x4 minus 4x cubed y plus 6x squared y squared minus 4xy cubed plus y to the 4. Now here it will be e I 4 alpha minus 4 times e I alpha to the power of 3 times this part. So we can simplify here. First one cubed, this one cubed times this one will be 3 alpha minus alpha 2 alpha. Then plus 6, it will be cancelled, minus 4 e I negative 2 alpha plus this one to the 4 e I negative 4 alpha. Now, this one we've calculated plus the next one. ei, look, you should only multiply by 2. It will be 8 alpha because alpha will change to 2 alpha. Minus 4 ei 4 alpha plus 6 minus 4 times e I negative 4 alpha plus e I negative 8 alpha. Now the last one, you should multiply this by 3 because alpha changed to 3 alpha. Changes to that. Let me control Y, okay. Now plus EI 12 alpha minus 4 EI 6 alpha plus 6 minus 4 EI negative 6 alpha plus EI negative 12 alpha. Now we want to simplify this. So let's see. We have 6 here, we have 6 here, we have 6 here, 18. Now let me tell you something. For example, when you say x to the n is 1, then sum of the roots, it has n roots. And if you want to consider sum of the roots will be 0. By what? By Vieta's formula. Why? Because let's see, xn minus 1, 0. And by Vieta's formula, you can say R1, we need coefficient of xn minus 1, which is 0. So R1 plus R2 to Rn equals 0. And it will be what? It will be all these roots. 1 here, for example, this angle, we have n roots. You should divide the circle into n parts. And this angle will be 2 pi over n. Or you can say 180 over n. Now here, alpha is what? Alpha is 180 over, for example, 7. And we understand that if you start from 1 and consider this 2 pi over n can be any theta. If it is theta and you divide the circle into equal parts, and the sum will be 0. Now let's see here we have what? EI 4 alpha. Because we know alpha is 180 over 7, we can consider negative these things are what? We know 7 alpha equal to 180 and 14 alpha equal to 360. So 14 alpha means 0. And then we can say, for example, negative 12 alpha is 2 alpha, similar to that. Negative 6 alpha equal to 8 alpha. Because of 14, 4 alpha, negative 4 alpha, 10 alpha. 14 alpha minus this will be 6 alpha. It will be 10 alpha. It will be 12 alpha. So we can write it is 1 over 16. 3 6 will be 18. And let's check each part. For, let me write with green. Negative 4 EI2 alpha. And this one will be negative 3. So it will be negative 3 EI2 alpha. This part we've calculated. Now let's calculate 4 alpha. We have 4 alpha here and negative 4 alpha. For EI 4 alpha, it will be negative 3 EI 4 alpha. We've calculated this and this. In next part, 6 alpha. This part and this part. It will be negative 3 EI 6 alpha. And it will be here and here. We've calculated. Next part, 8 alpha. This one negative 4, this one plus 1. It will be negative 3 EI8 alpha. And then for 10 alpha, we have plus 10 alpha and minus 410 alpha. It will be negative 3 EI10 alpha. And for 12 alpha, let's see this part, 1 and another one, this one, negative 4 will be negative 3 EI 12 alpha. And let's see, have we calculated all of them? For 8 alpha, negative 8 alpha here we had, and another 8 alpha is what? 8 alpha here, 6 alpha, 10 alpha, plus 1 minus 4, negative 3. So we've calculated all these terms and we want to see what happens. So we know that if we consider 2 alpha, if we start with 2 alpha, consider for example 2 alpha is beta. We start from beta, this one, then another beta, it is 2 beta. And then at the end we have what? We have 6 beta. And we know 7 beta is 14 alpha is 360. So we know sum of all of them. If we have 1, sum of all of them will be 0. So this part plus 1 is 0. So this part will be negative 1. And it will be 1 over 16. 18 plus 3 will be 21. 21 over 16. Now, because it is 21 over 16, if we replace here 7 times 16 times 21 over 16. And 16 will be cancelled. 7 times 21 is 147, and the answer is C. Okay, we solved this problem with complex numbers. If you want to learn all ideas related to complex numbers, all these things, have to relate a problem that you don't think it is possible to solve with complex numbers. If you want to learn all these things, feel free to send message to my WhatsApp number in the description and comments. Problem number 25 of AMC 12B 2022. It says 4 regular hexagon surround a square with side length 1. So it is 1 and the regular hexagon on each side. For example, one of them is this. For example, the other one is this. All these things. Each one sharing an edge with the square. As shown in the figure below, the area of the resulting 12-sided. 12-sided is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12-sided outer non-convex polygon can be written as m root n plus p, where m, n, and p are integers and n is not divisible by the square of any prime. What is m plus n plus p? Okay, so it is 1. And let's consider the center of the circle. If we connect this, we will see that by symmetry it passed through this point. And then I connect, let me consider this part is okay. It is O by symmetry and this. And if you see, we have how many of these figures? Let me call, for example, it is O, it is A, it is B, it is C. The answer is what times area of A, B, C, O? It will be 1, 2, 3, 4, 5, 6, 7, 8. It will be 8 times this area. Now, let's focus on and see how we can find the area of that. It says a square with length 1. So, now here I want to calculate. I say that this one is 1/2. This one is root 2 over 2. Okay, now in this figure it's a little better to work on area of AOBC or AOCB. This area, it will be 1/2. And if you want to calculate the whole area, if we continue, let me show with red, this part, it is 1, and if we draw this, because each angle is 120, you can say it is 90, it is 30 degree, and this part, if you draw, is 60 degree. So this part will be sine 60 times 1, root 3 over 2, or you can say it is root 3. And because it is 1, you can say this length is root 3 minus 1. And we found all these lengths, 1 over 2, root 3 minus 1. And if we continue also this part, they will be what? They will be a rectangle here that is 1 over 2. Let's call this one, for example, A, B, C, D. We didn't have D here. Yes. Okay, DE. So you can say it is area of BCEO, this rectangle, plus area of two triangles, EOD, plus area of ADB, or ABD. Now, area of BCEO is root 3 minus 1 times 1 over 2, plus area of EOD it is a right angle triangle, it will be 1 over 2 times 1 over 2 over 2 plus the next one AOD. Let's work on the angles. It is 45, it is 90, it is 45, then it is 90. Now this angle is 30, 30, 45, 75, and it will be 105. It will be 180. Now let's calculate. BD is root 3 minus 1. So let's focus on area of ABD. We can say area of ABD, it is half AD times BD times sine 45. BD is root 3 minus 1. Sine 45 is root 2 over 2. AD is what? If you want to calculate AD, I use sine rule. Then I can say AD over sine 30 equal to BD over sine 105. So because I want to find only AD, I know BD is what? BD is root 3 minus 1. And I say AD is BD, sine 30 is 1 half. BD is root 3 minus 1 over 2 times 1 over sine 105. For sine 105, let's calculate. Sine 105 equal to sine 75. And sine 75 is sine, it is equal to sine 30 plus sine 45. And it will be root 2 over 2. If you know the formula, if you don't know the formula of sine of two angles, feel free, or other trigonometric things, or have any question about the solution of this problem, feel free to send message to my WhatsApp number in the description and comments. It will be sine 30, which will be 1 half plus root 3 over 2. And we can say, if you replace, it will be root 3 minus 1 over 2 times reciprocal of this 1 over sine 105 equal to root 2 over 2. It will be root 2. It will be 2 root 2 over 1 plus root 3. And it will be 2 root 2, 1 plus root 3. And we cancel these two things. And it will be root 2 times root 3 minus 1, root 3 plus 1. So let's replace AD here. It will be 1 half AD is root 2, root 3 minus 1 over root 3 plus 1. BD is root 3 minus 1. And sine 45 is root 2 over 2. So let's simplify these cases here. We have root 2 again, divided by 2, it will be 2. And it will be root 3 minus 1 squared, root 3 minus 1 squared, 2 times root 3 plus 1. Okay, let's write all these things. Here we have this. If you add up all these terms, so let me write with different color. Root 3 minus 1 over 2. Let's write root 3 minus 1 over 2 plus 1 over 2 times 1 over 2 over 2 will be 1 over 8 plus 1 over 8 plus this part, root 3 minus 1 squared over 2 root 3 plus 1. Root 3 minus 1 squared over 2 root 3 plus 1. Okay. In first part, I say root 3 minus 1 over 2. Let's focus on this part first. If we want to rationalize, we can say root 3 minus 1 squared, it will be root 3 squared 3 plus 1, 4. 4 plus minus 2 root 3. And it will be 2 times root 3 plus 1. And if you divide both numerator and denominator by 2, it will be 2 minus root 3. And it will be root 3 plus 1. Then we multiply both numerator and denominator by root 3 minus 1. And the denominator will be 3 minus 1, 2. And it will be 2 root 3 plus root 3, 3 root 3, and then minus root 3 times root 3, minus 3, minus 2, minus 5, all over 2. So 3 root 3 minus 5 over 2. So let's write root 3 minus 1 over 2 plus 1 over 8 plus 3 root 3 minus 5 over 2. And if you use, it will be, if we add this part, because the problem says the answer is 8 times this. So if you multiply 8 times this, the answer will be 4 times root 3 minus 4 plus 1 plus 4 times 3, 12 root 3 minus 20. 4 root 3 plus 12 root 3 will be 16 root 3. 1 minus 4, negative 3. Negative 3, negative 20, negative 23. And the problem says it will be m root n plus p. So it will be m root n plus p. And let's see the problem wants what? M plus n plus p. It will be 16 plus 3, 19 minus 23, negative 4. And the answer will be B. Okay, if you want to know important things here, diagonals in hexagon, regular, let me correct this part. If you want to learn important things, like for example, diagonals in regular hexagon, also regular octagon, all these things, have to find areas, important things in quadrilaterals, all other things, and 40, 50 important formulas in geometry. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. We've solved all 25 problems of this year of AMC 12B 2022. Also, I released AMC 10A, 12A, and 10B of 2022. And also, I will release other exam solution. I release preparation before the exam, and we've solved many problems in this exam and also other exam with the ideas I told exactly the day before the exam of AMC 1012A 2022. So if you want to learn important ideas, 40, 50 important ideas that are useful in geometry, combinatorics, number theory, and algebra, and also other things for other math exams, feel free to send message to my WhatsApp number in the description and comments. And thanks for watching this video, and have a great day. And please don't forget to subscribe, turn on the bell, and like the video. Okay, see you next time. Bye bye.